Hi, and welcome to our channel Neurabytes. My name is Navjinder Virdee, and in this lesson, we will learn about how to traverse a linked list and how to find elements in a linked list. So, let's learn about these operations. First is traversal operation. Traversing a list means to go through each node of the list individually and then printing the data of each node. Next operation is find operation. Find operation is about finding a node whose data is equal to the given data that we need to find. It returns none if the node with the given data is not present in the linked list. Let's start with the traversal first. The first step is to create a temporary node and assign head to it. Let's say we are given the following list. After performing the first step, both the head and the temporary node are referring to the first node, that is node 10. The next step is to traverse the list until the temporary node is not equal to none. So while temp is not equal to none, we will print the data and then move to the next node. Initially, temporary node refers to the node 10. Then to the node 20, and then to the node 15, and finally to none. Hence, we can stop the while loop now. Let's code the function now. In the previous lessons, we implemented the node class and defined the head node and also implemented the insertion operations. If you haven't seen these videos, then I have provided the links in the description below. Please check them out. We also learned about the time complexities of these operations. Now let's implement the traversal operation. First, we will print the linked list to indicate the start of the list. Then we will create a temporary node and assign head to it. Now, while temp is not equal to none, we will print the data of the node. And then we will move to the next node. And finally, we will print none to indicate the end of the list. So that was our traversal operation. Now let's check it out. As you can see, we have traversed the list. We inserted 3 nodes using push front and 3 nodes using push back in the previous lessons. Now, let's learn about the find operation. The first step is again to create a temporary node and assign head to it. Let's say we are given the following list. Now, both the temporary node and the head are referring to the first node, that is node 10. The next step is to traverse the list node by node and on each node check whether the node's data is equal to the given data that we need to find. While temp is not equal to none, we will compare the data, and if the data is found, then we will return that node, else we will continue the search and move to the next node. Initially, we are at node 10. If the data to find was 10, then we had stopped here and returned the node 10. Now we are at node 20. If the data to find was 20, then we had stopped here and returned the node 20. Now we are at node 15. If the data to find was 15, then we had stopped here and returned the node 15. Now temp is equal to none. It is the case when we don't find the given data in the list, so we will return none in this case. Now let's implement the find operation. The first step is to create a temporary node and assign head to it. Next, we will go through the entire list until temp is not equal to none and compare each node's data with the given data. If we found the data, then we will return the node, Otherwise, we will continue our search and move to the next node. If we don't find our data in the entire list, then in the end we will return none. So that was our find operation. Now let's use it. We will be using the previous list in which we inserted 10, 20 and 30 using push front and 40, 50 and 60 using push back. Now let's find the node with data 20. It will print the data. Now let's find the node with the data 60. It will again print the data. Let's find a data that is not present in the list. Let's say 100. We will only print the node now, as it is going to be none. So that's it. Now let us go through the time complexities of these operations. The time complexity of the traverse function is linear in terms of the length of the list, where n is the number of nodes in the list. Because we have to go through each node of the list individually. The time complexity of the find operation is also linear in terms of the length of the list, where n is the number of nodes in the list. This is because the worst case is that we don't find the data in the entire list, so we go through each node of the list until the end. Thank you for watching this video. In the next lesson, we will learn about the deletion operations and start with some interview coding questions. If you liked the video, then please like, subscribe and share. And I'll see you in the next lesson.